Can you type in the chat? Just type anything. Like, so that I know the chat is working. Okay. So, hello. So as usual, I'll be waiting for the first 5 minutes for more people to join, and then I'll be starting with my usual thing. So, till the fifth minute, we will wait. If you have any questions you want to talk with me, just type in the chat, whatever you want. My voice is low. Uh, Better now? Hello, Ishita. Okay, is my voice better now? बढ़िया. So yeah, people who are joining now, I'm basically just waiting till the fifth minute for whoever wants, they can join till then, and after that I'll start. People on YouTube, there is a small delay, um, like of 10-20 seconds. But if you guys have any question, it might come to me late. So I will be join the class here. You can see the class link in the description and also my profile link. So you can find the class from my profile also. So join the class so that you get to see like completely live. ठीक है? हाँ, डीपी के जो भी प्रॉब्लम्स नहीं हो रहे हैं सेंड टू डिस्कॉर्ड. जो भी प्रॉब्लम नहीं हो रहा है जस्ट सेंड ऑन डिस्कॉर्ड वो टॉपिक रिक्वेस्ट में. आई विल पिन देम. If I find the problem interesting, I will discuss them in the problem discussion sessions. Otherwise, I'll skip them. Hello, Vamshi. अगर इंटरेस्टिंग प्रॉब्लम नहीं हुआ तब तो स्किप करूँगा ना. तब लाइक प्रॉब्लम डिस्कशन सेशन में स्किप करूँगा. बट if you have doubts, then I'll try to solve them in the Discord itself server. Yes, DSU is a data structure. No, it's not just an array. How is No, DSU not DSU isn't just an array. You use like two, three, I think, yeah, two arrays to make DSU. It's like you use arrays to implement heaps also. That doesn't make heap not a data structure, right? You use arrays to implement segment trees also. Segment tree is also data structure. Okay, so they are implemented using normal. I think I took a session on segment trees, iterative segment trees. DSU is the ADT. You implement it using arrays. Storing के लिए no, it's just arrays. Nothing else that I can think of. ठीक है, so let's start. People who are joining my class for the first time, hello, I'm Istasis Mishra. I'm a third year undergraduate in IIIT Hyderabad right now, and I've been to ICPC regionals twice and represented India in IY 2018 Japan. So that is like a small introduction for myself in case you are joining my class for the first time. Most of the people are like familiar faces here. I take classes every weekday, 3 p.m. to 3 to 4:30 p.m. But from next week, I have planned to change the timing. I think I will take it from 8 because most people voted for 8, but then I'm not sure when to take because 8 से तो कोड फोर्सेस का कॉन्टेस्ट रहता है 8 to 10. तो some people who solve code forces contests may not join on the days of contests. So I was thinking to make it like on days of contests I'll do at 3 p.m. otherwise I'll do at 8 p.m. ऐसा type का. So tell me in the chat if whatever you think. Hello Datta. So whoever are joining, thank you for joining. And yeah, I like the class to be a bit interactive, so I will be asking a lot of questions, waiting for the answers. Even if I ask ki if you understand or not, just type yes. It doesn't matter. Okay. After 10 p.m. apparently I'm not allowed. Like 9:30 is the max. Okay, anyway, so today's class is on DSU, and so not sure how many of you guys know the basic idea what DSU means. So initially I will start with a sample problem, like a problem that you just have to implement DSU to solve the problem, nothing else. Okay, so let's see if you can come up with the idea of DSU by yourself. Okay, so this way you will be putting your own brains into coming up with the data structure, and then we'll be solving two problems. One is a code forces div to F, and another is an educational round D. So first I will solve the sample problem. I will also implement DSU. So I will be implementing DSU and solving the sample problem. Of course, I can't submit it anywhere as of now. And then I'll be solving code forces div to F and educational round D. Okay? So two problems I'll be solving. To solve the two problems, you need to have some basic knowledge of graphs, which the people who are already doing my class for a long time will know because I have done like graphs ka problem solving बहुत ज़्यादा. Educational round is basically div 2 round, so it's the same thing. So I'll be sharing the link to both the problems and my implementation of DSU after the class. Okay? And again, DSU I have not. Okay, okay. I know. This is not important, so that is why I didn't put any effort into writing this. Okay? So this is just the idea for today. I'll start with a sample problem. We'll implement DSU, then we'll solve two problems. Okay? Okay. Then, so let's start the sample problem. The problem goes something like this: ki let's say you are given n number of sets. Okay? And then you are given q queries. Okay? And I think spelling galat hai. Anyway, so you are given q queries. In each query, you will be like each query will be of two types. Okay? Either it will start from 0 or 1. If it starts from 0, okay, you need to print. If it starts from 0, you'll be given two integers xy. So this means you have to merge set that contains x with set that contains y. ठीक है? So two types of queries. First query will be given, first will be 0, and then you are given two integers x, y. Both obviously x and y will be less than equals n. Okay? You have to merge the set that contains x with the set that contains y. And one case के लिए भी same xy, same constraint, you have to print yes if x and y are in the same set, or else no. Okay? So this is it. And n and q can be up to 10 to the power 6. Okay? So q queries, in each query, so basically there will be q lines. In each line you will be either be given 0xy or 1xy. If you are given 0xy, that means the two sets that contain one contains x, one contains y, you merge them both. If they are in the same set, do nothing. Okay? And if you are given 1xy, that means you need to just print if they are in the same set or not. Okay? Initially, there are n number of sets. So 1 is in set 1, 2 is in set 2, 3 is in set 3. So each number is in its own set. And then you start merging or printing if they are in the same set or not. Okay? So problem makes sense? X and y are numbers. So initially these are your sets. So let's say n is 5. Okay, so n is 3, let's say. So initially your sets are 1, 2 and 3. Okay? So if the first query is 1, 1, 2, you print no. Okay? And if the second query is 0, 1, 2, then your new sets will become something like this. And 3. Okay? And then you are again given 1, 2 and you print yes. So this example makes sense? So this is your problem. So any idea कैसे करना है? People on YouTube, you guys can also ask me doubts. It will be better if you join the class. Yeah. So join the class here so that your doubts are instantly solved, because YouTube mein there is a small delay of 10-20 seconds. 10-20 seconds. Okay, so few answers I'm getting. Vamshi says store the first number as king of the set, maintain an array for all the elements, and change the king whenever there is the union. Okay. So here individually, so let's say representative, let's call it representative, or instead of a king. Okay? So each set has a representative. This element is a representative of the set, right? So initially each will be representative of their owns, and just change the representative whenever there is a union. Okay, and सबको nodes मान लो initially, then 0 पर edge create कर दो. And 1 पे we can see that if there is any adjacency. Okay, ठीक है? I am not explaining anything. I'm explaining the solutions that I'm getting from people. So Vamshi का solution is कि each set का एक representative मान लो कि so set 1 का representative is 1, set 2 का representative is 2, set 3 का representative is 3. So after doing this union, the representative of this set is still 1, but 2 does not have a representative of its own. So something like that. And Muskan ka solution goes something like कि सबको एक node consider कर लो, create an edge whenever there is a union, and just see if there is adjacency. You can't check if there is adjacency. You'll have to check if they're in the same connected component. So something like, let's say you have 1, 2 and 3, 1, 2, 3, 4 you have, okay? So I make a union of 1, 2, then I make a union of 2, 3. So you need to and then I'm asking if 1 and 2 are in the same 1 and 3 are in the same set or not. So you'll have to do a DFS and check if they're one, like do a DFS from 1 and check if you ever visit 3 or not, something like that, right? Okay. So what is the complexity? You don't need to know connected component. Connected component, it just means that in this graph 1 and 4 are not in the same component. This is one component and this is one component. So 1 2 3 are connected, 4 is connected in itself. Okay. So you don't need to know anything about it, like it's easy stuff. Okay, so Muskan, do you understand your solution ka complexity? What will the complexity? Yes, you need to run DFS every time. So every time you get this query, you'll need to run a DFS, and the DFS will run in O of n time, right? Exactly. Actually, it's O of v plus e, right? So anyway, it's O of v only. So O of n. O of n for each query. So overall, it will be O of qn, and that will not pass, right? So और क्या solution आ रहे दिमाग में, मतलब good solutions, variety of solutions I'm getting, all of them kind of similar and they make sense, they're correct, but time limit के अंदर नहीं है. So let's try to optimize it. So we know a O of NQ solution now. O of NQ solution is to just think of each set as nodes, and every time you get a query of the union type, you create an edge between the two nodes, and you just check if they are in the same connected component or not for the other type of query. बार बार, ठीक है? So Vamshi, can you tell me more about your solution? Parent store करना है, ठीक है? But who will be the parent यहाँ पे? Like 1 2 3 में से एक को कौन parent होगा, कौन, like how do you know कि which one will be the parent and which one will be not the parent? Yeah, so you think of one set का एक king होता है, ठीक है? चलो, let's use the term king only, ठीक है? So every set will have a king. So if you merge your solution with Muskan ka solution, there must be a king of this set, right? So Vamshi ka solution says कि every set has a king, ठीक है? And whenever you want to check if x and y are in the same connected component or not, you check x का जो king है, is that equal to the y ka king? So king as in representative. King means the one, like one node represents the whole component. Okay? If you merge it with this solution, one node will represent this whole component. So what node? So each node should have some special node, right? Each component. Yes, you number the sets. So initially, let's say 1 2 3 and 4 ऐसे, ठीक है? Then I want to make 1 and 2 my like I want to union between 1 and 2. How do you decide which one will be the new king? Initially they are kings of their own, ठीक है? So I join 1 and 2. How do you decide which one of them will be the king? And उसके बाद if I join 2 and 3, which one will of them will be the king? Okay, initially every element is parent, and when we merge element, ठीक है? So one Ardhendu gave me one सोल्यूशन की सेट का साइज देख के हम किंग लेंगे, ठीक है. If I want to join 1 and 2, I'll make this edge, but king can be any one of them because both of them have the same size initially. 1 1 ही था size. So let's make 1 the king, ठीक है. And so my new looks something like this too. So king को मैं root बना देता हूँ, ठीक है. And then you have 3 and then you have 4. And if I want to make a union of this set and this set now, ठीक है. Like let's say I want to take union of 1 and 3, ठीक है. There are two options. Either I can make 1 the child of 3 or I can make 3 the child of 1. Ardhendu says कि let's take the set with the larger number of nodes and make उस set का जो root my parent of the root of the current set. So something like this. So instead of making 3 the parent of 1, I make 1 the parent of 3 because this has a size of 2 and this has a size of 1. So bigger set ka root will be the parent of smaller set ka root. So that is Ardhendu ka solution. So till now 3 people have contributed to the solution. Muskan said the graph wala idea. Then Vamshi said the representative wala idea. Right? So king को कैसे represent कर सकते हैं हम? As a root, right? एक component का जो root होगा, that will be my king. But how do you decide the king? That Ardhendu told कि keep making parents. How do you make the parent? The two sets you are taking the union of, the bigger set का जो root होगा, make that the parent of the smaller set का root. And how do you check if two nodes are in the same component or not now? If they have the same king. So king कैसे कर सकते हैं? Just keep going to the parent. So if the two nodes have the same root, then we will always we know कि they are in the same component, right? What if there are cycles? If there are cycles, then तो parent का cycle बन जाएगा. Like so let's say 2 is parent of 3, 1 is parent of 2, and 3 is parent of 1. So in this case, you will keep going in a cycle. And let's say like initially you made 3 ka parent as 4, but then you changed 3 ka parent to 2 because naya query aaya. So that is a problem, right? So you can prevent cycles by checking if they're in the same component already or not. If they're in the same component already, then you don't need to make a new edge, right? Yeah, so now let's say 2 sets, okay? This is my one set, and let's say this is my second set, okay? So what I'm doing, I'm making this the parent of this. So I'll do something like this. That is exactly what I'm doing. So smaller set का जो root होगा, I'm making the larger set का जो root है, I'm making that the parent of the smaller set का root. Right? If both sets have the same size, we take any of them the root, like randomly. It doesn't matter which one you take. Okay, can someone now tell me the complexity? What is the complexity now? And why did taking the larger set ka is helping? Like why can't I make it the other way around? The complexity is still O of n, nahi? Because to see if two nodes are in the same component or not, I still have to reach to the root. I have to go to the root, right? And going to the root, some constant into n. Okay. Yeah, this is the question. This is the question now. This is the question that uses DSU. So I used a question to introduce the idea of DSU. So you are learning DSU while solving that question. Okay. So one answer says O of log n, y, and another answer says some constant into n, again y. Even if it's some constant into n, it's O of n only, right? Per query. So it will be O of qn per overall. So it still doesn't pass, right? Ardhendu? And Vamshi, tell me why O of log n? Yeah, per query, what is the complexity? Is it constant? Okay. Why? So one answer says O of log n, one answer says O of 1. Which one of them is correct and why? I say it's O of n. Shouldn't it be O of n? For, yeah, for, nahi, even for 1. So one answer tells me ki for this type of query it's O of n. Actually ulta hona chahiye, I think. For this type of query it's O of n. For this type of query it's O of 1. Right? Because iske liye I'll have to travel to the root. But iske liye will I have to travel to the root? I'll have to travel, right? Because if I want to merge this and this node, I still have to travel to the root, and then root ko I'll make parent of the other root, right? So I still have to travel to the root. In both cases, I'm having to travel from the node to the root. So it's O of n for both queries. What if we store the parents already? So 1 per O of n होना चाहिए. हाँ, 1 per O of n ही हो रहा है. So you keep going to the parent. Okay, we'll come to that later, Ardhendu. इसके लिए मेरे को बताओ कोई what is the complexity? We can have a hash map for the parent. Hash map नहीं चाहिए, एक array बना दो. Make P an array. So P of I is parent of I. So one array. Okay, this is log n. Why? Two people are saying कि complexity here is log n instead of n. Okay. Okay. So this is O of n, right? Both queries will take O of n per query. एक काम करता हूँ, मैं पोल बनाता हूँ, ठीक है? So A O of n, B O of log n, C O of log n, and D O of 1. So just tell me what you think is the time complexity of the current solution that we have, ठीक है? Per query, ठीक है? This is per query. Per query, what is the complexity that you have? Worst complexity. Atisha, you want me to repeat this whole question? This question or the question that I'm asking now? Oh, I'm asking per query, what is the complexity of the algorithm we have as of now? How is that worst? Nahi, that is the best. If everything is different set, then finding the root is O of 1, nahi? Worst is if they make a chain. Right? Because then traveling to the root will be stuck ho gaya. Is the video stuck? Okay. 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 Thank you. So, okay. So most people are saying it's O of n. So, and someone said it's O of log n. Who thinks it's O of log n? Is there anyone who thinks it's O of log n? There must be at least one person because someone answered B. बोलो भाई, कोई तो होगा. चलो, he or she is not coming forward. तो whoever you are right. ठीक है, this is, इसका complexity is O of log n, not O of n. So let me explain why. O of n तभी होगा when going from a node to the root, you have a this path का length is n, right? But think about it a bit. Whenever you make an edge, you make from root to root. So this was a component of its own, this is a component of its own, and you, let's say this is the parent, ठीक है, and this is the child, the new child, ठीक है. So this was a component on its own, and this is a component on its own, ठीक है. Whenever you make that, imagine इसका size will be x and इसका size will be y, right? So x is less than y, less than equals y. Is this clear? Because small larger set का जो root होगा, I'm making that the parent of the smaller set का root, ठीक है. So I can say that x is less than equals my let's remove this, ठीक है. X is less than equals y. So anytime, so imagine like this, you are going ऊपर, ठीक है, you'll keep going ऊपर. If you go one up, so what is the, so इसका जो subtree size होगा, that will be x. What is the minimum subtree size of the parent? If this node, if the node u has a subtree size of x, what is the minimum subtree size of the parent p? x plus 1 कैसे होगा? इसका जो पहले सबट्री था, that must be y is greater than equals x, right? So it must be x plus y, right? But I know that y is less than equals x. So x plus x is less than equals x plus y, which is my subtree size of p. So 2x less than equals subtree size of p. So the minimum subtree size of p will be 2x. Okay, I'm explaining. u का subtree size is x, p का subtree size except u is y. So p का subtree size क्या होगा? x plus y. But x is less than equals y. I added x to both sides, right? So x plus x will be less than equals x plus y. This is subtree size of p, and this is 2x. So subtree size of p must be at least 2x, right? So u का subtree size is x, p का subtree size will be at least 2x. So p के parent का subtree size will be at least 4x. So if I go to the parent, if I go to the parent L number, hello, am I here? ठीक है, I'm sharing my screen. एक बार अब देख लो कि if it's visible. Is it visible now? Is the code visible now? बढ़िया, चलो. So let's implement then. So it was my internet, so changing that helped. ठीक है, okay, let's just start coding it. It went out again. ठीक है, it is my internet today. The screen is still visible? ठीक है, बढ़िया. तो yeah, so I need two arrays, right? Two vectors I'll need. one to track the parent and one to track the size, right? And यहाँ पे I'll first take n and q. I'll do this, and let's resize the two vectors. Okay, so now I have size should be all ones, and parent, actually let's initialize them. Initially parent of I will be equals I, right? They're parents of, like, the root is a parent of itself. That is what I'm trying to do. Okay, and sz, actually there's a smaller implementation. Do what? Initially all the sizes will be 1 and all the parents will be -1. Okay, so parent of a, if parent of a node is -1, that means that it is the root. Okay, so let's do find root function first. Find root of x. Okay, so find root of x, size 1, because size of each set initially is 1, right? Size of the ith set is 1. Nahi. Why will it be empty? Initially there are n numbers, each number is in its own set, nahi? Okay, now find root function. First, if pair of x is equals -1, then I just return x, right? Because then x is the root. This makes sense? Otherwise I return pair of x equals find root of pair of x. Make sense? So I'll apply find root on pair of x, and I'll change my pair of x to that, because that will be my new root. So this is basically doing path compression while going up. Is this function making sense now? So it's recursively going to the parent, and parent say as soon as I find the root, I will change the parent of my xth node to my root, right? Does it make sense now? Amazing. So now let's do merge. I'm merging int x int y. Okay, now first I do x will be find root of x and y will be find root of y. So now instead of random nodes, they are roots of the two components. Now I will check if size of x is my less than size of y. Okay, let's say greater than. If this is there, then I just swap x and y. Okay, now right now size of x is less than equals size of y, right? We have ensured this. Hello shape AI. Okay, now we have ensured this. So x is the smaller component. So what do we need to do? Pair of x will be equals y, right? Pair of x मेरा initially -1 होगा. This swap line, I'm just ensuring कि size of, like, x is the smaller one. Swap xy will swap the values of xy, in case you didn't know the function. So if size of x is greater, then I swap xy. So I'm ensuring that size of x is less than equals size of y, so that I can change my parent of x to y, right? See, there are two ways. Okay, I could do this. Otherwise I can do this. If size of x is less than equals size of y, then pair of x equals y, else pair of y equals x. This is one way of doing it, but this I am just doing doing this way. Okay, make sense? So if I swap, now I'm ensuring कि x is the smaller component का root, y is the larger component का root. ठीक है? And one more check I need to do. If x is equal to y, then I need to return. I need to just return. It should return void. ठीक है? If x and y are in the same component already, I don't do anything. ठीक है? Yeah. So pair of x equals y, and then size also I need to change. So size of y plus equals size of x, right? So y is my new root. So x is my parent. So y के size के साथ I'm adding x का size. So these two lines, they make sense. This is the merging part. ठीक है. So now while q minus minus, I first take int txy, int txy, if t. So the type 1 wala query. So I will do what? So I need to do x minus minus y minus minus, because there will be one indexed. Size of x equals 0. Why? Size of x doesn't matter anymore, right? I only, like, it can be anything, right? Because x is not a root anymore. It's only the root ka sz values that matter. Pair of x equals y. Yeah, pair of x equals y. Parent of x will be y, because x is the smaller component, right? So let me just write this. So type 1 query, if find root of x is equal to find root of y, then cout they're in the same component, else cout no, and else merge xy. So this is my code, right? So if t is 1, then I am seeing if they're in the same component or not. I'm just applying find root, and I'm checking if they are equal or not. Otherwise I'm merging them. So this is it. This is your whole DSU. Any doubts? Ask me. If there are no doubts, let's move on to you can give a link to submit this. Sure, give me send me the link. Let's try to submit this. Let me try to so yeah, semicolon. Okay, you sent on Discord. Let's see. I think I'll have to make an account here. Can I log in through GitHub? No, I can't. That is. Can I submit without logging in? Let's try this sample. Is 0 you okay, so I'll have to change my code thoda sa, because 0 means adding an edge. 0 means adding an edge. Oh, I don't even have to change my code. It's the exact same problem. Okay, chalo. I can literally just submit this. So first NQ, then okay. I did not expect this. Let's see. Let's try to run the code. So 47, then 101 is a yes. So instead of yes, no, I need to print 01. So if connected, print 1. If connected, print 1. If not connected, print 0. Oh, initially, yeah. So the problem is this -1. So I have to change it. because everyone has root of -1, right? So it'll always, initially it'll always say yes. So I less than n, I plus plus, pair of I equals I, and here I need to change x. Amazing. So this is not needed anymore, and this remains equal. So 4 7 1 0 1, it's still 1. Okay, so I don't need to do this. 4 7 1 0 1 0 0 0 1 and 0 2 3 1 0 1 1 and 1 1 2 0 0 0 2 1 1 3 1. Okay, okay, I'll try to submit it now. Do I sub language? Yeah, I'll tell what changes I did. Oh, it got accepted. But yeah, thank you, Vamshi. Yeah, we will do one more question. I still have time. Don't worry. So the change that I did was, initially I was initializing all the parents with -1, right? So this find root of x and find root of y will always give -1, both of them, and they will be equal. So I was saying they are in the same component. So that was wrong. So I changed parent of I to I. So initially the root ka, the parent is itself. And here I needed to make this change. Instead of, this was initially -1, I did x. Okay, so this is the code. Okay, does this make sense? Swap, there is nothing happening. I'm just like, x will be the smaller component, right? After this, after line 37, will x be the root of the smaller component or not? X will be the root of the smaller component, right? Instead of y. Like, x is the root of the smaller component, y is the root of the larger component. So just to ensure that, I want x to be the smaller component, y to be the larger component. That is exactly what I'm doing. If x is the larger component, then I'm swapping, so that x is the smaller component after the swap, right? But that is exactly what I'm doing. I don't even know how to show it on board. It's just like making sure that x is the smaller component. So in case x is larger, I swap them so that x becomes smaller. Okay? So this code I'll be sharing after the class, and let's move on to the next problem. Okay, I don't know why I stopped sharing my screen. Screen visible, problem visible. So I think I can only do one of these. So div1d or div2f. Bolo kaun sa? Div1d or div2f, choose. Rating. What do you mean rating? Rating, you 2400 and 2300. Which one? The high rated one, 2400. So div2f. Atishay wants me to do this. Vamshi wants me to do this. This is actually, I find this one easier actually from this. दोनों तो नहीं होगा. There's no chance दोनों होगा. यही करते हैं, इसका प्रॉब्लम स्टेटमेंट भी छोटा है, ठीक है. सो हार्डर वाला कर रहे हैं. सो लेट मी, ताकि मैं चैट देख पाऊँ वाइल द प्रॉब्लम इज बिंग सॉल्व्ड. इसको सही कर देता हूँ. प्रॉब्लम दिख रहा है? So I will not be implementing this abhi, but I will try to share my code by tonight. ठीक है? So you are given a tree with n vertices. On each, like from each node has a value ai. So ith node has a value ai. So you are denoting ixy as difference between the maximum value and the minimum value on the path from x to y. So your task is to calculate for every pair, for every unique pair, you have to calculate I of ij. So basically max minus min. N can be up to 10 power 6 and ai can be up to 10 power 6. So do you want me to explain the problem on board? It goes something like this. Ki suppose the path is like this and the values on the nodes are your, let's say, 2 4 6 1 2. Okay. So if you are going on this path, you are doing max minus min. So this path ka I value will be equals your 6 minus 2 equals 4. This you need to do for every pair of nodes. समझ में आ रहा है? For every pair of nodes, you do this, take the sum. That is what the 2 sigmas mean. इस path में find the maximum value which is 6, find the minimum value which is 2, do 6 minus 2, difference between maximum and minimum. 6 minus, oh acha, 6 minus 1, sorry, yes, you are correct. So I will be 6 minus 1 equals 5, sorry. This you have to do for every pair of node. So what will be the answer for this tree? It will be 2 minus 2 0. So for every node, max minus min will be 0. So 2 4, it will be 2. This path it's 2. This path it's 4. Plus this path it's 6 minus 1. It will be 5. Plus whole path will be 5. Then this path will be 5. This path will be 5. And this path will be 1. So finally I have this as my answer for this tree. Okay, one solution. Okay, now I'm stopping the share so that people can start sharing their solutions. Okay, what are the paths? Arey, so paths will be something like this, na? So this is my tree, right? And each of the nodes had what value? 2 4 6 1 2. 2 4 6 1 2. So this is one path, the value of that will be 2, plus this is one path, the value of which will be 4. This is one path, value of which will be 5. This is one path, value of which will be 5. Then this is one path, 5. This is one path, 5. And this is one path, 1. And any more paths left? So you are getting, right? So for every path you do max minus min. Okay. Okay, so one solution I got. min max स्टोर करेंगे पेरेंट के साथ. अच्छा, so min max स्टोर करेंगे पेरेंट के साथ, ठीक है. min max स्टोर किया, देन ईच मर्ज के टाइम मैक्स माइनस min इनटू दोनों का सबट्री साइज. क्या किस ऑर्डर में मर्ज कर रहे हैं हम? ऐसे रैंडमली मर्ज कर रहे हैं? नॉट श्योर सोल्यूशन क्या है. फॉर ईच स्टोर सेट 2 पेरेंट्स, ठीक है. एक मैक्स एक मिन. how are you processing the set? You can't iterate in all parts. N is less than equals 10 power 6, I think. It was, right? N is up to 10 power 6. So you can't iterate through all paths. There will be n square paths, if not more. Just a second. I will get some water. एक second रुको. I'll get some water. Yeah, and Ardhendu, तुम्हारा solution, I am not sure what you mean by merge के time max minus min into दोनों का subtree size store करोगे. So like किस order are you doing a DFS and then merge करते जा रहे हो? थोड़ा सोच के बताओ, मैं थोड़ा पानी लेके आता हूँ. Yeah, I'm back. Yeah, I will share the question link in my Discord. Are you a part of my Discord? I'll just share the link. Just a second. So I shared the link to my Discord. I pinned it. The problem links, like after every class, I share the problem links and my solutions if I submit them in the announcements channel, announcements and resources channel. Yeah, so you are merging for every edge, but are you just processing every edge randomly? What is given? Edge का order. हाँ, edges is given, but in which order are you processing the edges? कुछ भी random order में process कर रहे हो? Will that even work? Not sure. So Ardhendu का solution is something like कि उसके अंदर max and min store करना है. So every set में I'm storing my pair तो store कर ही रहा हूँ. मेरा size भी store कर रहा हूँ and max भी store कर रहा हूँ and min भी store कर रहा हूँ. So these both I can update easily for a set. ठीक है. तो max and min store कर रहा हूँ. Whilst so each edge I'll process and initially ये disconnector थे. Connect जब किया मैंने, connect जब किया तब it will be max minus min, like max here and min here into size. Okay, no, not like this. Find the new max new mix. हाँ हाँ. तो size I into size j. So assume this is I and this is j. So size I into size j multiplied by max minus min. ये है ना solution? This is wrong, right? Because what if एक node है जो इससे connect होता, but ये connect होने से पहले ही मैंने ये आंसर ऐड कर दिया. No, I am not discussing. Ardhendu gave me a solution and I am trying to figure it out and trying to see if it's correct or not. So, Ardhendu, what do you do about this? Yeah. नहीं, size I into size j multiplied by max minus min, right? तो यहाँ पे जितने nodes हैं multiplied by यहाँ पे जितने nodes हैं, that many paths are there multiplied by max minus min. Wait, that won't work. Okay, तो size I plus size j, ठीक है. Then what? Then max into min multiplied by max minus min. This is the answer. I have no idea why. Size I plus size j into max minus min. Why? So you are saying there are size I plus size j number of paths. Okay, assume दो नोड्स हैं, इसका 2 है एंड इसका 1 है. तो जब मैं ये करूँगा सो इट विल बी 1 plus 1 multiplied by 2 minus 1. So it will become 2, which is wrong, right? The answer should be just 1. So इस example में तो it's not working. If you told me कि size I into size j तब तो थोड़ा सा make sense, but size I plus size j why? I'll wait for like 20 more seconds. अच्छा चलो, I'm discussing. So the solution goes something like this. So you had to find this, right? Max minus min. So what you can do is you can separate the max minus min. Max minus sum of min, right? So like among all paths, you had to find max minus min. So you just separated the two. So first you find the max, sum of all the maxes in every path, and then you find sum of all the mins in every path, right? So what you do is work with the nodes in increasing order of like first let's try to find the max. ठीक है? Yeah. तो increasing order of AI से you start doing it. ठीक है? तो assume there is a node and let's say इसका value is 5. ठीक है? So there it has some number of children. Assume these are the number of children, and initially these like it is connected, but they are not like connected in the DSU yet. So I have a DSU, I keep a DSU, and I only work with the nodes that are in the DSU till now. Okay, so assume, so since I'm doing it in increasing order, so assume that this is something like 7, 6, 3, 2, 1. These are the values of these nodes. So 7 and 6 I will not process because I'm working with the nodes in increasing order of their values. So 7 and 6 I will not work with them. I'll only think about 3, 2, 1. So 3 will have a component, 2 will have a component, 1 will have a component, right? And they are not connected to 5 yet. So 3 ka component, 2 ka component, and 1 ka component. Each of them are only working with nodes that are less than equals 5. Less than equals 5 होना चाहिए. if 3 has a child 6, then that is also not processed. So every path I can look at it as passing through 5. So number of paths passing through 5, if let's say that is s number of paths pass through 5, okay, then s into max I need to add to my answer. So answer plus equals s into max. So I am working with nodes in increasing order of like their values. Okay. So after processing some number of nodes, I came to 5. So this is the node 5. Okay. Node 5 say I look at every node adjacent to it. So let's say there are 5 nodes adjacent to it, and their values are 7, 6, 7, 6, 3, 2, 1. Okay. 7 and 6 I do not process because they are not processed yet. Like 5 के बाद 6 आता है ना, and I'm processing them in increasing order of their values. समझ में आ रहा है? तो 5 को I'm processing, I will not look at 7 and 6. I'll only look at 3 to 1. So 3 to 1 will have their own components in their DSU, right? And even in their components, if 6 has a node, if 6 has a node 6, if 3 has a node 6, if 3 has a node as a child that has a value of 6, then that has not been processed yet. So even in 3, it's not a part of this DSU. So 3 के component में, like in the DSU, is node का set में whatever values are there must have all the values less than 5. So I can look at every path that passes through this node. Let's call that S. So उस path में the maximum must be value 5, right? So 5 into S must be contributed to my answer. So answer plus equals S into 5, right? The number of paths multiplied by my maximum. So the maximum will be 5, right? Make sense? So ये number of paths कितना होगा? इस DSU में I'll find इसका all the जो भी S जो भी मेरे सब ट्री साइजेस हैं, सब ट्री साइजेस सपोज ith नोड का SI है सब ट्री साइज अभी के लिए, ठीक है? तो how many nodes? 3 पार्ट्स का into 2 to the power what? 3 का पार्ट्स, अच्छा 3 का पार्ट्स into 2 का पार्ट्स. हाँ, no, you don't multiply all of them. It's 3 का पार्ट्स multiplied by 2 का पार्ट्स plus 2 का पार्ट्स multiplied by 1 का पार्ट्स plus 1 का पार्ट plus 3 का पाथ multiplied by 1 का पाथ, right? Like number of nodes in 3 multiplied by number of nodes in 2 plus number of nodes in 3 multiplied by number of nodes in 1 plus number of nodes in 2 multiplied by number of nodes in 1, right? So it's summation of Si into Sj, right? For all ij. So दो summations होगा, right? This is not the complete yet because you also have to take this as the end node also. So इसको अगर end node लोगे, explain this one. Sij, अरे 5, 3, 2, 1. So 3 का subtree size is S3, 2 का subtree size is S2, 1 का subtree size is S1. How many paths pass through 5? The number of nodes in 3 multiplied by the number of nodes in 2, nahi? S3 into S2. The number of paths that pass through 5 is number of nodes in 3 multiplied by number of nodes in 2 plus number of nodes in 2 multiplied by number of nodes in 1. plus number of nodes in 3 multiplied by number of nodes in 1. हाँ, plus S3 plus S2 plus S1 plus 1. So this is passing through 5. This is 5 as one endpoint, and this is node 5 itself. Right? So the whole sum S will be equal summation of Si into Sj plus summation of Si plus 1. Right? Multiply this whole thing with your value, which is 5, and you have all the nodes that pass through 5. So increasing order of values में process them, every time do this. Then इसके बाद क्या करना है? इसके बाद इन सबको सेम DSU सेम कंपोनेंट में डाल देना है DSU का. ये करते जाओ तो तुम्हारा मैक्स वाला पार्ट निकल गया. देन डिक्रीजिंग ऑर्डर में एक बार S3, S2 are not path lengths. S3 is the number of nodes in subtree of 3. Number of nodes in subtree of 3 multiplied by number of nodes in subtree of 2. So that is your path, right? Because in path you will pair each of them. Make sense? So that is why S3 into S2 will all pass through 5. S2 into S1 will pass through 5. S3 into S1 will pass through 5. And this part is when 5 is one endpoint. If 5 is one endpoint, S3 को each of दी जाएगा. इसका code is very easy. It's just DSU, right? क्या है इसमें? DFS कहाँ कर रहे हैं हम बस इंक्रीजिंग ऑर्डर ऑफ द नोड्स में जा रहे हैं. सब ट्री साइज तो DSU में ना, DSU में द साइज ऑफ द कंपोनेंट. DFS की जरूरत ही नहीं है यहाँ पे. Exactly, just one sorting and then DSU, then another sorting you need to do in decreasing order to find the minimum. So increasing order में करने से you find the maximum, decreasing order में you find the minimum, print the difference in the two and you found your answer. Right? कोई doubt इसमें? Yeah, for increasing order you found the minimum, right? So increasing class extend मैंने 10 minutes से किया but नहीं हो सकता. Like मेरा अपना काम भी है ना तो. So this is it. Increasing order में करने से 5, so 7 and 6 has not been done, right? But if the same thing you did in decreasing order, ठीक है, then 5, 7, 6, 3, 2, 1. If you did in decreasing order, then you will be processing 7 and 6 and not 3 to 1. Right? नहीं, मैं internship नहीं कर रहा, मैं अपना research कर रहा हूँ. So wait, so if you process in decreasing order, you find the minimum. If you process in increasing order, you find the maximum. My research is in ML models, extreme multi-label classification. ठीक है, so YouTube में हम ending